guys, it's Professor McDonald. In this video, I'm going to give you a quick lesson on all the important items, introductory items in this list here. And it's just going to be kind of a mini lesson, introduction to ordered pairs, the rectangular coordinate system, the distance formula, the midpoint formula, and equations in two variables. So I'd like to start off with some things that are really simple, some kind of pop quiz items just to see how you line up with what you should be aware of so far. And I'm going to be using these elements as we go on throughout the lesson. So the first thing I'd like to ask you is, what is this called? This would be called a number line, right? It's just a line that shows numbers in order, and we have 0 here. If you move to the right of 0, you get 1, and then if you move again, you get 2, and 3, and 4, and so on. If you start at 0 and you move to the left, you're going to be going into the negative, so it's like subtracting 1. Subtracting 1 again, and you get negative 2. Subtract 1 again, you get negative 3. Okay, so that's a number line. That's pretty simple, right? Now, what happens if we move from 0? I'm going to show it like this. Move over 1, right? So 0 plus 1 equals 1. What about moving 2? 0 plus 2 equals 2. 0 plus 3 equals 3. Pretty cool. No big deal. What about going from here and we go 0 minus 1 equals negative 1. 0 minus 2 jumps equals negative 2, and so on. Okay, that's pretty obvious. What about if we move, say, the 0 point somewhere else? So let's say we start at 1 and we move from 1 and we move 1 jump, then it would be 1 plus 1 is 2, the new location. Or 1 plus 2 jumps would get us to 3, and so on. All right, same thing if we subtract from 1. 1 minus 1 equals 0. 1 minus 2 equals negative 1, and so on. So that's a number line and ways to illustrate locations on the number line by counting jumps from a certain point. All right, so that's a number line. Now let's think of it as there's so many possible numbers on this number line. Let's give it a variable name and just say that wherever we go on this line, it's going to be some value. And let's call it, in general, x. Let's just call it x. And x is going to vary. So depending on what we're doing, we'll let x equal different things. So if I move my dot, say, over here, then x equals 2, right? If I move my dot over here, then x equals 4, and so on. All right, now let's make it a little more interesting. What if I make this line vertical? All right, so if I move upward, I'm moving in the positive direction, and if I'm moving downward, I'm moving in the negative direction. So why don't we say have 2 of these things together, and then we already know the first one we've named x, and let's make the second one here our y. All right, so we'll let the vertical direction be y and the horizontal direction be x. So now we can move side to side on the x-axis, and so x can be different values, and y can be different values by moving up and down on the y-axis. But we also are no longer restricted to addresses that either lie on the x number line or the y number line. We can also have points somewhere in one of the quadrants here, like maybe 3, 4. So that is where I represent the move to the right of 3. My x is 3 there, and my move up is y. And actually, I'm going to color code a little better here. we'll stick with green for X, and we'll use orange for Y. Okay, so by moving to the right 3 and up 4, I get a central location with an address 3, 4. So that's an ordered pair. The order is understood by convention to do X's first and then Y's second. And by using that address, you can get to a location on this, what is called a rectangular coordinate system, or the Cartesian plane. And so you guys probably are familiar with that already. But there's other points we could look at. We could look at, say, -3 and +4 over here. So notice that the y value stayed the same while the x value changed, and they're the same height because the vertical location, the vertical address is the same, but the horizontal version is negative now. What about the point -3 and -4? So we change the sign of both of these, and we'll have this point right about here, right? And what about if we keep the x value positive, but we change the sign of the y value? Then we would be down in here, right here, right about here, 3 and 4. Okay, so those are different locations in the rectangular coordinate system, and they are each in a different quadrant, a different quarter of the plane. And we can name these quadrants. The first quadrant is always the one where both x and y are positive, positive, positive. And so this would be called quadrant 1, and they're marked with Roman numerals. So that would be quadrant 1. And then we move counterclockwise. So we're going to move now to this quadrant, and this will be called quadrant 2. And notice that in quadrant 2, we have a negative and a positive. Make these color-coded here. All right, so a negative and a positive is quadrant 2. A negative for x and a negative for y, though, would be in quadrant 3. And a positive for x and a negative for y would be in quadrant 4. All right, so that's an introduction to coordinates in general. And we've looked at number lines and their locations and their relationship of different points to each other. And I'd like to come back to this for a moment because we are going to be talking about the distance formula soon. So let's do some explorations with distance that are very simple. Okay, so I'm at 0 and I move to 4. You can see that I have traveled a distance of 4. Now, to get the difference between 4 and 0, we would subtract 4 minus 0 and get a difference of 4. Or in other words, you could kind of reverse the way I have this here and say that if you start at 4, you're going to have to move backwards 4 units to get to the other point. So there is a difference of 4 between them, right? And you can find the difference or the distance, and they're interchangeable. Difference, which means to subtract, is equivalent to distance. So any 2 points, I want to know the difference between -3 and 4, or the distance between -3 and 4. There's a difference of 7. And if I were to show that here, I would do 4 minus -3, and the double negative would become a positive, and so we would end up with a distance of 7. So that's on a regular number line. All you have to do is subtract the two numbers to find out how many jumps are between them. But what about, let's say I have this point down here, and this point over here. So I have the point 0, comma, -5 and the point 4, -3. And maybe I want to know what is the distance between those 2 points. Well, now I can no longer simply only subtract, you know, I can't just subtract on the number line here. It's more complex. I have a diagonal distance. So how do we deal with that? Well, the way we deal with that is with the distance formula. So here is the distance formula, and this is something that you memorize typically, but I've noticed that students will mix this up oftentimes with another formula that you're going to be using called the midpoint formula. So we're going to learn how to distinguish between the midpoint formula and the distance formula. The distance formula, notice you subtract the x's, so you get that horizontal distance, and you subtract the y's and you get that vertical distance. And then you do a bunch of other stuff, and we're going to talk about why it makes sense that we do that other stuff. But it's important for you to just make the connection right now with the word distance and the fact that you are subtracting the x's from each other and subtracting the y's from each other. When we go on to the midpoint formula, you're going to be doing some adding. And actually, let's look at the midpoint formula now. Okay, so the midpoint formula, first of all, it's a point. So it's an x comma y, all right? And x is horizontal and y is vertical address. Horizontal location, vertical location. So it is a point, first of all. Second of all, it is mid, which means middle. It's the middle point. So what we're going to talk about later will explain more about why this formula makes sense, but the midpoint formula is simply an x and a y value, but they come from using point coordinates of two given points, x1 and x2, and two y values, one for each point, right? And so notice that you're adding here. And the quickest way to remember that is that it's a midpoint. So another type of measure of center that you may be familiar with is called the average. So let me do a little pop quiz here. 2 plus 3 plus 4. How do I find the average of those numbers? You add them together and you divide by how many numbers you have, right? So 2 plus 3 is 5, plus 4 is 9, so 9 divided by 3 equals 3. So the average of the numbers 2, 3, and 4 is 3, of course. Now, if I showed you that on a number line, so you can see here's 2, here's 4. What is the middle point? It's 3, right? So I want you to remember this. The midpoint is nothing more than the average of two numbers. So to get the midpoint, you're going to want to take the average of the x values to get your new x value for the midpoint, and the average of your y values to get the coordinate for your y in your midpoint. And that's it. So, I mean, if you have to memorize, you memorize, but the key things to remember here are that the distance formula, distance and difference are synonymous. Difference implies subtraction, right? And with the midpoint formula, it's a measure of center, it's an average of 2 points, so you will be adding your x values before dividing by 2, okay? So hopefully that'll help you keep those formulas separate in your mind. But what we're going to talk about in more length is the distance formula and how it's so cool, the distance formula, and it's something that you can memorize, but I can explain it in a way that you might not actually have to just memorize it. And it's going to come in handy if you understand this lesson. It's going to come in handy in many different other areas within this course, and even for future courses if you do take any other math courses. So let's get into it. Let's talk about what the distance formula is and how to never forget it again. Okay, so here we have a rectangular coordinate system with your x-axis across the horizontal, your y-axis on the vertical, and they are intersected where each of the number lines are at 0. And the point in the center, many of you may know, is called the origin. The origin has the x-coordinate of 0 and the y-coordinate of 0. Okay, so that's called the origin. So we're going to talk about not only how to find the distance between any 2 points with one example so that we can extend it to other scenarios. So we're going to look at the point 3, 4 again. So here, if I move to the right of the origin, 1, 2, 3, and then from there move up 1, 2, 3, 4, then I have the point 3, 4. Now, what I want to know is what is the distance between the origin to this point 3, 4. Now, I could simply use the distance formula, but there's a way to use the Pythagorean theorem. And before I even get into why I know I can use the Pythagorean theorem, I'm going to show you how to use a circle from the origin. We're going to go to the point 3, 4, so over 1, 2, 3, and up 1, 2, 3, 4. Okay, so now I know that I have a circle that is centered at the origin, and then I have a point on the circle with the coordinates 3, 4. And I want to know what is the distance between this point and this point. All right, now to find that distance, I'm going to have to figure out how far I would have to move to get here. But I have one thing as an advantage is that this circle from the center out to any point on the circle has a certain radius, and that's what makes it a circle. When you just have a point and a long piece and you keep the point centered and you just move the piece around, um, you get that same size from the center all the way around. So whatever the radius is, that's the distance from the point in the middle to the circle. That's called the radius, and that is clearly what the distance is here. Well, I can count on the x-axis 1, 2, 3, 4, 5, and see that this has a radius of 5, so I know the distance of this point is 5. Okay, fair enough. That was easy, but what if you don't have a circle, or what if it doesn't perfectly line up so nicely? We can still use mathematics in a clever way to get the answer here. And what we're going to do is we're going to use special formula called the Pythagorean theorem. And the Pythagorean theorem only works for right triangles, so we're going to need a right triangle. Well, it's very easy for me to use this side of the triangle as one side of my, this line segment as one side of my triangle, and then I'll use this distance for the x coordinate as one of the legs of my triangle, and I'll also use this vertical distance as another leg of my triangle. And then I have a perfect right triangle. And I can use the Pythagorean theorem to find missing pieces of my triangle. And with mathematics, as long as you only have one missing piece of information in an equation, you can always solve for that missing piece. So do we have only one missing piece? And I've already done it over here, color-coded. Let's assume that we don't know what this distance is yet because we didn't use a circle, okay? We're just going to use algebra to figure it out. So we don't know what that distance is right there, and we want to know. But we have these other elements. We have this leg of the triangle, which we know has a length of 3, and we have this leg of the triangle here, which has a length of 4. And we know that it's a right triangle because there's a perfect 90-degree angle here. And we can use the Pythagorean theorem for this. The Pythagorean theorem only works for right triangles, which we have, so we can use it, and it's a squared plus b squared equals c squared. Okay, so let's fill in what we have. Now c is special C represents the hypotenuse of the right triangle, which is always the longest side and the one that is across from the 90-degree angle. So this would be C. And that's what we're trying to find out. The other two legs can be A or B. It doesn't really make a difference which one, but we'll just stick with using A as the horizontal and B as the vertical. And so now we can just replace, in this formula, we can replace the A with 3 and the B, replace it with 4. And then we don't know what C is, so we'll leave that as an unknown. And now we have all numbers except for that one letter. And so that is our one missing piece of information that we can solve for in order to answer our question. So we'll just go ahead and simplify, and we'll get 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25. Okay, and now this is a pretty easy one to figure out without doing any more math. If you just know that, hey, I know if I do 5 times 5, I get 25, so the answer must be 5. But what we would do in mathematically or algebraically is we would try to undo this power of 2 by taking the root, the second root, and that would effectively cancel out the power of 2. And we would do that to both sides to keep everything balanced. And when we do it on the side opposite the unknown, we always put a plus minus because it's true that both 5 squared will give you 25 and also negative 5 squared will give you 25. So we always allow for the possibility of a negative result. But in this case, we're going to ignore the negative because we know that C is a distance and distances can't be negative. So that leaves us with only one possible answer, and that is that C equals 5. All right, so what we have just done is we have used the distance formula in a more creative way. Let's take a look at that distance formula again. The distance formula is written as B equals the square root of two squared quantities added, right? And what are the differences there? X1 minus X2 and Y1 minus Y2. Okay, and if we just use the 2 points, the two coordinates for the X values, we'll get the difference. That would be our A side, and the difference of the two Y values will give us our B leg, and then this would end up being our C over here. So A squared plus B squared equals C squared, and if you take the square root of C squared, then you're left with just C. So the distance formula and the Pythagorean theorem formula are actually the same formula. Now let me prove it to you using the coordinates that I had. I had the coordinates 0, 0, and 3, 4, right? So my x1 could be 0, my x2 could be 3. For my y coordinates, my y1 could be 0 and my y2 could be 4. So using the distance formula, if I had it memorized, would just work out. So that's 0 minus 3 and 0 minus 4. And so it would work out to negative 3 quantities squared plus negative 4 quantities squared. So negative 3 times a negative 3 is a positive 9. Negative 4 times negative 4 is positive 16. So we get the answer square root of 25, which is just 5. Okay, pretty cool, huh? Now, the other thing that's cool about the distance formula and the Pythagorean theorem and how they all come together is the center radius form of a circle. Center radius form of a circle. That lesson is in a future section, but just to give you a preview, the center radius form of a circle is written like this: x minus h quantity squared plus y minus k quantity squared is equal to r squared. Now, doesn't that look a whole lot like a squared plus b squared equals c squared? So the center radius form of a circle is also the Pythagorean theorem, where your x and y represent any point anywhere on the uh, circle, and your h and your k just represent the actual middle of the circle. So the center of the circle is h comma k, and of course r is the radius. Okay, and so any circle can be graphed if you know where to start the middle of it and how far out to make your radius. And then once you have that, here's my center, if I know where that is on the coordinate system, and then I have my radius, however long it is, then I can keep that middle point fixed and just rotate that length all the way around to create a circle. That's how a compass works. You know, those things with the little needle and the pencil, and you set the width and you just pull it around, you make a circle, because any circle is defined. Another way of saying defined, you could say drawn. A circle is drawn if you know where the center is and how long the radius should be, and then you can make a circle. So all those concepts are connected. We'll get into circles more in another section. And as I said earlier, all these concepts are going to be very useful to you in other areas in the course. So what we talked about in this lesson, we started off with ordered pairs and the rectangular coordinate system, which is the graphing plane. Then we talked about the distance formula and the midpoint formula. We didn't get into the midpoint formula in as much depth, but we did talk about the fact that it is the average of both the x values and the average of the y values. Add them together and divide by 2. And then what about equations in 2 variables? Now, we didn't really talk about that explicitly, but we were doing equations in 2 variables. For instance, the equation of a circle is an equation in 2 variables because it involves the x variable, so where it's going to be horizontally, and where it's going to be vertically. So anytime you have a situation that would require information about the horizontal and the vertical locations of things, that would be an equation that would have an x and a y in it, and that would be called an equation in 2 variables. So I hope you've enjoyed this introductory mini lesson to the section. Please go ahead and work on your participation assignment, and I hope you have a more enjoyable experience now with rectangular coordinates and graphs now that you've seen this video. Take care, and I'll see you in the next one.